All right, let's do a third example for solving trig equations. This is example number 3. Let's read this together. We have cotangent of x times cosine squared of x is equal to 2 cotangent of x. So this can be a very complicated looking problem, and I want to prevent you from some pitfalls that may occur with this problem. But again, you just want to go through the same 9 steps that I've taught you for solving these problems, all of which have a reason and all of which I will reiterate why. What is theta? So again, actually this should be asking what is x. Let me change that. Okay, remember x can also represent an angle. It doesn't have to be theta. For x between 0 and 2 pi. Okay, so what angle x between 0 and 2 pi satisfies this equation? Again, this domain is important, otherwise we might come up with infinitely many solutions. We're going to follow the same steps, so let's go ahead and do that. And I know 9 steps is a lot, but as you understand why they exist and as you practice this, I promise you'll get the hang of it and you'll have no issues at all. And if you do, just let me know. Move all the trig functions to the same side. Okay, so the first thing we're going to do, since the 2 is kind of attached to the cotangent, is we're going to subtract that from both sides, move it over. So it's going to become minus 2 cotangent of x right here. So again, step 1 is to move all the trig functions to the same side. Step 2 is to write all the trig functions in terms of the same angle, preferably a single angle. Well, that's good because all of these are in terms of x. It's not 2x inside or x over 2. So step 2 is complete as well. Everything is in terms of the same angle. Step 3, if possible, convert all the trig functions into the same function using formulas. Now I'm going to make a note about this. Cosine and cotangent do not show up in the same formula. So we're going to move on. Now, if you don't believe me, if you don't want to take my word for it, look up quotient identities, look up Pythagorean identities, look up double and half angle formulas. Cosine and cotangent don't show up, okay? And if we try to write cotangent as cosine over sine, it's just going to become more complicated. So we're going to have to move on from this step, which is why it says if possible. Remember, that's how an algorithm works. You go through the process, but you don't always do every step of the algorithm. You just check to make sure, right? It's kind of like when you're baking a pizza. Before you put it in the oven, you make sure that it's prepared correctly, right? And if it's not, you adjust it. So you don't always have to adjust it before you put it in the oven, but sometimes you do. Step 4 is to replace trig functions with a variable. So in this case, I have 2 trig functions. I have cotangent and cosine. So I'm going to call my cotangent A and my cosine B. Okay, so now I'm going to replace cotangent of x with a and cosine of x with b. So I have ab squared minus 2a, since cotangent of x is equal to a. And that c right there looks weird. I'm going to try to fix that for you real quick. Let's see. There we go. It looks a little bit better. Okay, so ab squared minus 2a equals 0. Now you might be thinking, how in the world are we going to solve this if we have 2 different variables? Well, in fact, you can by doing some factoring. So I'm going to pull an a out of both of these because I'm going to underline this. Both of these have an a, so I'm going to pull that a out. I'm going to be left with b squared minus 2. That's pulling out the GCF. Then I'm just going to set each factor equal to 0. A is a factor, so a automatically equals 0. And b squared minus 2 is equal to factor. So I'm going to set that equal to 0. So I'm going to add 2 to both sides. So move that 2 over. Let's show that. And then take the square root. Don't forget plus or minus when you take the square root, right? And then so you get b is equal to square root of 2, or b is equal to negative square root of 2, and a is equal to 0. So again, step 5 is to solve for that variable that you replaced in step 4, replacing those trig functions with a variable, just to make it a little bit simpler instead of looking at a bunch of these trig functions. Plus, you can kind of do the algebra much quicker. Okay, you don't have to do that step, but I think it makes it look easier and a little bit easier. Step 6, replace the variable with the trig function. So we said a was cotangent and b was cosine, so that's all we're doing in this step. I'll actually try to draw some arrows. Is we're just replacing the variables with what we said they were equal to. Step 7 is to take the inverse trig function of both sides. So to get x by itself here, we have to take the cotangent inverse of both sides to cancel this cotangent out. And same thing on over here. Take the cosine inverse over here, and we're doing it on both sides so that we can cancel the cosine, so that ultimately we can just have x by itself. So we get x equals cotangent inverse of 0, x equals cosine inverse of square root of 2, and x equals cosine inverse of negative square root of 2. So that's step 7, taking the inverse trig function of both sides. Step 8 is to solve for the angle. So what is cotangent inverse of 0? Well, remember, there is an identity. It's called the inverse reciprocal identity for trig functions, which basically says that cotangent inverse is equal to tan inverse of 1 over x. So cotangent of 0 is equal to tangent inverse of 1 over 0. We know 1 over 0 is undefined, so now we just have to think where on the unit circle is tangent undefined. I'm going to draw a mini unit circle down here, and I'm not sure if you can remember this or not, but since tangent is y over x and x is 0 right here, then tangent's going to be undefined at pi over 2 and 3 pi over 2, which means cotangent would be equal to 0 there. Okay, so those are our two answers for that. I'm going to go ahead. I'm not going to box them in because we do have to check our solutions. And then where is cosine inverse equal to square root of 2? Well, that's going to be undefined. Square root of 2 is bigger than 1, right? Square root of 2 is equal to about 1.4, which is bigger than 1. And there's nowhere on the unit circle where cosine is bigger than 1, because cosine is adjacent over hypotenuse. The adjacent side is never bigger than the hypotenuse, so it cannot be bigger than 1. It can be equal to 1 at 0 degrees, but it can't be bigger. And same thing over here. It can't be less than or equal to negative 1 for the same reason. So undefined for both of these, so these will not apply, but this actually did. Right? We got two angles here. And we do want to check by plugging those back in to make sure, and sure enough, for step 9, check by plugging in. When we plug in pi over 2 and we plug in 3 pi over 2, we get 0 equals 0. So they both check out. So we will go ahead and box in. Let's use a different color here. I like red. These are our two answers. Now, the last pitfall I want to tell you about before I close this video out is something that I had a student ask me about several years ago, which was a great observation. Absolutely nothing wrong with this observation, and I totally understand why he was thinking this. But he said, well, why not just divide both sides by cotangent of x to begin with? Because cotangent of x might be equal to 0, and you can't divide by zeros. So by dividing by cotangent of x to start out with, that would be nice, right? We would just end up with cosine squared equals 2. But that would eliminate a possible solution, and we just showed you, we just showed that x could be 3 pi over 2 and pi over 2, and which would make those cotangents equal to 0. Okay, so just follow the steps, no canceling, don't divide, move the trig functions to one side, and you'll be fine. That's it for this example. If you have any other questions about this, let me know.